ABS Hydraulic Control Unit, HCU, is located in the engine compartment. The hydraulic control unit receives operating signals from the ABS ECU, to apply or release the brakes under ABS conditions. The modulator unit controls the flow of pressurized brake fluid to the individual wheel circuits. Pressure modulation refers to the rapid cycling of pressure to the brake assemblies, preventing wheel lockup. The pressure modulation occurs 15 to 20 times per second. There are two types of ABS hydraulic modulator, integrated with ABS ECU, and non-integrated with ABS ECU. The pump motor, hydraulic control unit, HCU, and control module, are mounted together in one compact assembly. ABS hydraulic control unit contains HCU block, solenoid valves, fluid accumulator, pump and electric motor. The hydraulic block contains the pump that is used to generate the pressure required to lock and release each wheel at high-speed intervals. An electric motor drives a pump inside the HCU unit. The HCU may have one pump and one motor, or it have one motor and two pumps. To avoid wheel lockups, the pressure at each individual brake is controlled via valves in the hydraulic modulator. The solenoid valves are located in the modulator unit, and are electrically operated by signals from the control module. The solenoid valves control the brake pressure to the wheel brake assemblies. These solenoids provide three operating modes during ABS operation: pressure holding, pressure reduction, and pressure increase. These valves can cycle many times per second. The valves modulate the brake pressure up to 20 times per second. The rapid modulation of brake pressure in a given brake circuit reduces the braking load on the affected wheel, and allows it to regain traction. There are two types of ABS systems distinguished by the actuator: two-position solenoid valves, and three-position solenoid valves. Two-position solenoid actuators use two solenoids per brake assembly, one inlet valve and one outlet valve. There are two types of two-position solenoid valves, normally open, and normally closed. A normally open inlet valve allows fluid to flow from the master cylinder through the valve and to the brake units. Pressure holding valve controls the circuit between the brake master cylinder and the wheel cylinder. The valve is spring-loaded to the open position, normally open. When current flows in the coil, the valve closes. A spring-loaded check valve provides an additional release passage when pressure from the master cylinder drops. A normally closed outlet valve blocks fluid from flowing back to the accumulator, reservoir, or pump. Pressure reduction valve controls the circuit between the wheel cylinder and the actuator reservoir. The valve is spring-loaded in the closed position, normally closed. When current flows through the coil, the valve compresses the spring and opens the valve. In two-position solenoid hydraulic circuit, the actuator consists of 6 or 8 two-position solenoids. 2 solenoids are used to control each wheel hydraulic circuit. ABS hydraulic modulator has 4 operating modes: normal mode, non-ABS mode, and 3 ABS active modes: hold, decrease, and increase modes. During normal braking, as the rotational speed of the wheel falls, no electric current flows from the ECU to the hydraulic unit. The solenoid valves allow brake fluid to freely flow through the hydraulic modulator to the brake unit, and the ABS is not involved. The solenoids are not energized, so the pressure holding valve remains open, and the pressure reduction valve remains closed. When any wheel begins to lock, the ECU initially goes to hold mode to prevent any additional increase in pressure. The ECU turns off the pressure reduction valve and turns the pressure holding valve on. The pressure reduction valve closes, preventing hydraulic fluid from going to the accumulator, and the pressure holding valve remains closed, so no additional fluid pressure can reach the wheel cylinder. When the slip ratio of any wheel exceeds 30%, the ABS control unit energizes both the holding valve and the reduction valve. The pressure holding valve closes and blocks pressure from the master cylinder. The open reduction valve allows hydraulic pressure from the wheel cylinder circuit into the accumulator, reducing brake pressure and allowing the wheel to start rolling again. The pump is also energized to direct hydraulic fluid back to the master cylinder. This causes brake pedal feedback and alerts the driver to ABS operation. As pressure inside the wheel cylinder is reduced, and the speed sensor sends a signal indicating that the speed is above the target level, the ECU turns off both the pressure reduction valve and the pressure holding valve. The pressure reduction valve closes, preventing hydraulic fluid from going to the accumulator, and the pressure holding valve opens, so additional pressure enters the wheel cylinder if the driver maintains pedal pressure. The operation is the same as normal mode except the pump is on. The pressure holding valve and the pressure reduction valve are separate valves in two-position solenoid actuators. But in three-position solenoid actuators they are combined into a common assembly. This assembly has one electric solenoid that operates the valve in 3 positions, one position for apply, one for hold, and one for release. In normal non-ABS braking, the signals from the wheel speed sensor show no tendency for the wheel to lock up, so the ECU is not sending any control current to the solenoid coil. The solenoid valve is not energized and the hydraulic pressure from the master cylinder is supplied to the brake unit at the wheel. When the ECU detects any lockup tendency, it sends a command current to the solenoid coil, and causes the armature and valve to move upward and isolate the brake circuit from the master cylinder. This stops the braking pressure at that wheel from rising and keeps it constant. If the sensor signal continuing excessive wheel deceleration, the ECU sends a larger current to the solenoid valve. This lowers the braking pressure by moving the armature up further, opening a passage from the brake circuit to an accumulator, a temporary reservoir for any brake fluid that flows out of the wheel brake cylinders, because of the fall in pressure. If the wheel sensor indicates that lowering the brake pressure is letting the wheel accelerate again, the ECU stops sending current to the hydraulic unit and de-energizes the solenoid valve. This lets the pressure increase so that the wheel is again decelerated, and normal braking can continue. This cycle repeats itself about 4 to 6 times per second. It is normal in an ABS for the valves and the hydraulic control unit to keep changing position, as they change the brake pressure that's being applied. These changes in position may cause rapid pulsations to be felt through the brake pedal.